All right. Hi, guys. Welcome to our next topic on factoring. A lot of this you have seen before. Actually, all of it at some point you have seen before. And we've already actually reviewed some of the types of factoring. But now we're going to review all the types of factoring that you've learned. So you can see that box there. There's all 6. So maybe when you're doing your math Excel or on your warm-up, you can look at this to kind of refer back to which type of grouping you should be doing, or which type of factoring you should be doing. So to get started, we always start when we teach factoring with GCF. We already talked about this. You always do this first. So do first, always. So we practice this in our first unit, our review unit, unit 0. Here's an example. You're looking for what is common between all the terms. So 3, 6, and 12 has a 3 in common. So that's why the 3 is pulled out here. And they also have x to the second. It's always the highest exponent. So we take out 3x to the second. What you're doing, and most of you just do this in your mind, is you're really dividing it to each term to see what's left. That's how you decide what's in the parentheses, okay? You don't have to show that step. Most of you just do that in your mind. And when you do that, you get x squared plus 2x minus 4. So you need both the GCF and the leftover result. This is also reverse distribution. So you can always check your answer by multiplying back in, and when you multiply back in, you should get what you originally had, 3x to the 4th plus 6x cubed minus 12x squared. Sometimes you're done. All you need to do is factoring. Sometimes there's more to do. So after that, we've got 3 different types of problems where there's 2 terms. So this next part here, I'm going to group these together. These are the possibilities if you have, let me see if I can write here, 2 terms. So if you have 2 terms, these are your options. We have difference of squares, difference because there's a minus sign, and they should be squares. We have difference of cubes. So once again, there's a minus sign, but this time they are cubes. We have sum of cubes. This time it's a plus sign and they're cube problems, okay? So squares are numbers like, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. Cubes is still 1 to the 3rd is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, etc. That's just to start off some of the cubes that you should be familiar with, okay? And when that happens, you're going to follow the pattern that it says. One thing that is really, really important to note is if you ever see x squared plus a squared, that is prime. If you ever see a sum of squares, that is prime. You cannot factor that. Some people try to. It's not possible. If you FOIL whatever you think it is back, it does not work. So make sure you know that. Most people have the difference of squares memorized, but not the difference of cubes and the difference of sums. You need to have that memorized. So if you look at the signs for a minus one, so the difference one, if I take a look at the minus signs, if it's a minus problem, it's going to be same, changes, and always positive. So I always like to also think of it as SOAP. Don't forget your SOAP. And SOAP is going to stand for, the first sign is the same sign. The second one is the opposite sign. So the beginning one was negative, so now it's positive. And then the last one is always positive. See how the first letters, S-O-A-P, spell SOAP? So even when you do the sum of cubes for the signs, it's the same sign, so it's positive. Opposite of positive is negative. And then the last term is always positive. Okay, so don't forget your SOAP. That will help you with the signs. Otherwise, you just need to know which terms go where. So this has to be memorized. We say it right there. You have to know that. It's not new to you. You have seen it before. I know because I taught Algebra 2 with some of you. Okay, the next one is when you have 3 terms. And they call it trial and error, but really there's other ways to do it. So for this example, because there's no number in front of the x squared, it's just a 1, you could go ahead and look for two numbers that multiply to -3 and add to 2. So that would be 3 and -1. So you go right into factoring. So this is one type. The second type is split the middle. And we have been doing split the middle since the last unit. And that's when there's a number in front of the x squared. That's when you have, and I'm going to put it down here, ax squared plus bx plus c. So that's when you have that a there. Okay, then you have to split the middle. And we've done that in class already. And then the last type is grouping. And this is if you have 4 terms, you look to group. So notice how there is literally 4 terms, 1, 2, 3, 4. And you should know how to do this because 4 terms is just a problem like split the middle. So what you're going to go ahead and do is you're going to group the first 2 terms, just like it does here. And then you're going to find the GCF of the first 2 terms, which is x squared. And then you're going to group the last 2 terms. And really, you should include the sign in your grouping. I'm going to fix this problem. Your parentheses should go here and here. And what you do is when you take the GCF of that second one, the x minus 1, you should pull out a 1 in the front. So that way, once you take the GCF of both groups, you should always get in the parentheses the same thing. They're both x minus 1. So that's one of your answers. The other one is the leftover part, the x squared plus 1. That becomes the other factor. Okay, so the grouping, the 4 terms, is going to turn into 2 binomials. Okay, so we're going to do some examples, and I'm also going to have you do some. So example 1, difference of squares. So for difference of squares, we've been practicing this. X squared is a perfect square of x. 49 is a perfect square of 7, and it's telling you to use the difference of squares. So you should be writing this as x minus 7 times x plus 7. And if you wanted to check, all you would have to do is FOIL. You don't have to, because I think at this point, most of us are very quick at this one. Okay, next one, you might be like, whoa, what's going on here? Well, really, this is kind of like the problem x squared minus 25, in the sense that I'm replacing the x with 2a minus 3b. So really, this here is the x, okay? So something is being squared minus 25, and we know 25 is also a perfect square. So if you look at the easier problem, x squared minus 25, that would be like saying x minus 5 times x plus 5, because it's a difference of squares. But instead of the x is actually 2a minus 3b. So what I'm going to put in that place is really 2a minus 3b minus 5 times, and you can use parentheses or brackets, 2a minus 3b, and this time it's going to be plus 5, okay? So I'm subbing for these x's 2a minus 3b. That's what I did. I replaced those x's with 2a minus 3b in the difference of squares formula. And then I would just go ahead and we can simplify that a little bit. There's no terms that you can combine, so I'm just going to write it like this. So you would look to combine, but there's nothing. There's no like terms. We want to keep it in factored form. Do not multiply that out. Your answers are in factored form. So example 2 says factor using greatest common factor and difference of squares. So we have to pull out a GCF and then continue to do a little bit more. So let's take a look here. We're going to go ahead and take out a 2x. And that's going to leave you with an x squared minus 25. So you should notice after you do GCF, now you have a difference of squared. So now the x squared minus 25 turns into x minus 5 times x plus 5. So that one used both, just like it said, a common factor, so GCF and difference of squares. Part B, same idea. You look for the GCF. The GCF is 3x, which leaves you with x to the 4th minus 1. And that is a difference of squares, because the perfect square of x to the fourth is x squared. So this ends up looking like x squared minus 1 times x squared plus 1. And then you might notice you still have more that you can factor. There's x squared minus 1, which is another difference of squares. So we did GCF, difference of squares, and difference of squares again. So my final answer is x squared minus 1 turns into x minus 1 times x plus 1. But x squared plus 1 stays the same. We don't have a sum of squares. That cannot factor. That's FOIL. That's prime. X squared plus 1 stays. Okay. Next one. Factor using trial and error. I just like to think of this as 3 terms, multiply to the third, add to the second. So we're looking for 2 numbers that multiply to -5 and add to -4. So that would be -5 and 1. And you can just jump straight to the answer. So x minus 5 times x plus 1. Again, you can go straight to the answer because the number in front of the x squared is a 1. There's no number there, so you can go straight to the answer. You don't have to split the middle. All right, for the next problem, I'm going to go ahead and say stop, and you're going to try this one on your own. All right, welcome back. Hopefully you've got this answer. It's in Algebra 1, so 2 numbers that are going to multiply to 16 and add to -10 are going to be, you probably did a bunch of thinking in your head. You've maybe tried 4 and 4, that didn't work. But you can do -8 and -2 because -8 times -2 is +16 and -8 plus -2 is -10. So I can go straight to the answer of, and if you do what I do, which is use an X instead of a B, just be careful. So B minus 8, because especially Math Excel, you know it reads exactly what you're saying, times B minus 2. Done. All right, next one says factor by rewriting the middle term in grouping. So this is split the middle. That's what we're talking about here. We want you to split the middle. Again, the reason why you have to split the middle is because there is a number in front of the x squared, a coefficient we like to call that. So notice there's a 2 and a 3 here. So for both A and B, you cannot jump to the answer. You have to split the middle and show some work. So if we take a look at the first one, part A, we're going to do 2 numbers that multiply to 4 times 2 is 8 and adds to 9. So pretty easy, 8 and 1. Literally notice how I'm splitting the middle up into 2 numbers, 8x and +1x. You still bring down the last term and you bring down the first term. Then I'm going to go ahead and group the first 2 terms, and I'm going to group the last 2 terms. So the first 2 has a GCF of 2x, and I'm left with x plus 4. The other one I can pull out only a 1, which leaves me with an x plus 4. So that is pretty much telling you your 2 factors now. X plus 4 is one of them, and 2x plus 1 is the other. So that's going to tell you your factors. All right, looks good. And really, it's 2 lines of work until you get to the answer. So it's not like it's that much work. It's just obviously more work than example 3. Okay, part B. Since I have done a bunch of these in class now and in your notes, I'm going to have you stop and I'm going to have you try this one. All right, welcome back. We're looking for 2 numbers that multiply to -30 and add to 13. So if I go ahead and I think multiply to -30, you can't do 10 and 3 because they would both have to be, it wouldn't make, to get -30, one of them has to be negative and one of them has to be positive. So you have to do a combination of 15 and 2. If we want it to be 13, it's going to be a positive 15 and a -2. So we're going to have a positive 15x minus 2x. So I split the middle. I still bring down the last term, minus 10. I still bring down the first term. Now I'm going to go ahead and group my first two terms, and I'm going to group my last two terms. The GCF of my first term is 3x, which leaves me with x plus 5. And the GCF of my other two terms is negative 2, which also leaves me with an x plus 5. So once again, that's going to tell me what my two factors are. So one of them is x plus 5, and the other one is 3x minus 2. Does not matter the order that you write them. If you did the 3x minus 2 first, that's fine, but obviously the signs and things like that in the parentheses need to be the same. Okay. Next one says check by trial and error that these are irreducible. This is really important because this is where I see people make those mistakes. There's no such thing as a sum of squares. In fact, sometimes I have a hard time even saying it because it's not even a real thing. There is no such thing as sum of squares. Doesn't exist. Some people try to make them exist, for instance, for x squared plus 9, and they try to do, oh, x plus 3 and x plus 3. But if you FOIL that out, you're going to get x squared. You get a middle term. You get a 3x and another 3x, and then a plus 9. The plus 3x makes a plus 6x. It is not equal to it. It is prime. Next one, sometimes you're going to see a trinomial that is prime. You might be looking for two numbers that multiply to 3 and add to 2. There isn't anything. Nothing multiplies to 3 and adds to 2. The only multiples of 3 are 1 and 3. 1 and 3, if you FOIL that out, gives you x squared plus 3x plus 1x plus 3. That 3x and 1x is going to end up giving you a 4x in the middle, not a 2. So this is also one that is prime. Prime just means you can't factor it, okay? All right, let's take a look at the next set. We're going to go ahead and look at factoring by grouping, which should be very easy because we already know what to do with 4 terms because we use this in our trinomials when we split the middle. So just like with split the middle, when you have 4 terms, you're going to group the first 2 and you're going to group the last 2. Notice how I always include the sign in the second grouping, that plus 10x. I make it a plus 10x. I include the sign. So the first one, this one is not going to work. I am going to change this problem. I did not mean to have a bad problem here. We are going to change this problem. We're going to cross this off here. And we are going to make this problem 6x squared plus 15x. Sorry about that. Okay, so we're going to group the first 2 with the new problem. And that new one has a GCF of 6x squared and 15x. You can take out 3x, which leaves you with 2x plus 5. The second one, you have a GCF of 5, which leaves you with a 2x plus 5. And remember, these should match up. The 2x plus 5 should match up with the 2x plus 5. That's one of your factors. And the other one is 3x plus 5. So that's going to be your answer. So again, does not matter the order that you write them. If the 3x plus 5 is the first binomial or the second, does not matter. All right. The next one does work. I'm going to go ahead and do it with you just because you might be like, oh my gosh, there's a bunch of letters. You do exactly the same thing. It does not matter that it is all letters. So you're going to go ahead and group the first 2, and you're going to group the last 2. The first one has a GCF of A, so that's what you take out. You take out an A, which leaves you with x plus y squared. The second one has a GCF of B, which leaves you with x plus y squared. notice again that these two are the same, x plus y squared and x plus y squared. That's one of your terms. The other term is going to be the a plus b. So that is grouping when you don't have numbers. You follow the same thing. All right, we're down to the last type. And this is usually the one where if you don't memorize, you're going to have some trouble. It says factor using the sum and difference of cubes, okay? So that formula is on the other page. That's the one where I said don't forget your SOAP. That tells you what your signs are, okay? And it always factors into 2 terms times 3 terms. So a binomial times a trinomial. First, I know that it is a cube problem because the perfect cube of t cubed is t, and the perfect cubed of 125 is 5, because 5 to the 3rd power is 125. So you have to kind of keep that in mind. So we're going to go ahead, and if you look at the formula, or if you have it memorized already, that is great. So you're going to start with your parentheses, and your t and your 5 are going to go in the first spot. So this is t and this is 5. And then you're going to have a trinomial here. So I like to fill out the sign. Since it's a minus problem, don't forget your SOAP. So it's the same side, the opposite sign, and then always positive. Okay, and that's why there should be 3 terms here. Sometimes I see people do 2 terms times 2 terms. It's not going to be right. You need 3 terms there to fill in. So the terms are always going to be, it's the first term squared, so t squared. The middle term, you're going to multiply the t and the 5. That becomes 5t. And then the last term is going to be the second term squared. So we're saying, what is 5 squared? And 5 squared is 25. So I'm just following the formula on that other page. So again, you need to have that memorized. If you do multiply that back out, it does simplify to part A, t cubed minus 125. I'm going to go ahead and do another one with you just to get the practice in. You guys are going to get a lot of these by yourself anyways. So if we look at part B, you want to ask yourself, it's a sum problem, and are they perfect cubes? Yes, the perfect cubed of 8 is 2, because 2 to the 3rd power is 8. The perfect cubed of 27a cubed is 3a, because 3a to the 3rd will give you that 27a cubed. So those are your perfect cubes. I like to write them down sometimes. It helps me. Do you have to? No. So I know, don't forget my SOAP. Same sign, opposite, always positive. So when I put my signs, it also tells me how many terms I should have. So the first parentheses, I literally just put down the perfect cube. So I literally just write down 2 and 3a. The next one is going to be the first term squared. So what is 2 squared? That's 4. The middle term is the 2 multiplied, 2 times 3a. That's 6a. And then the last term is going to be 3a squared. Make sure when you do 3a squared, you get 9a squared. Do not just put 3a squared. That is wrong. 3a squared means 3a times 3a, which is 9a squared. So that's it. The sum and difference of cubes, you either know the formula or you don't, because there's no work to get to that one. It's not like, you know, grouping or split the middle. All right, so that's it on your entire review of factoring and all the different types that you know. I will be seeing you in class. Have a good day.